All right, today we are going to finish chapter 2. I've been saying that forever, but now we're going to do it because this is the last section. Transformations. A transformation is just that. It's a change. Trans means to change or move. Formation, you're moving a formation from one formation to another. And that's exactly what's happening here. Which is also why I asked you guys 2 weeks ago to memorize that library of functions. Because this will make it much easier if we do this stuff. So there are 5 changes we're going to do today. The first one, we're going to do a horizontal shift. That's left and right. Then we'll talk about vertical shifts. That's up and down. Then we'll look at reflections. There's a reflection about the x-axis. That's that way. And about the y-axis. That's that way. Then we'll talk about vertical shrink and stretch. That's pushing the function that way or that way, stretching it. And then lastly, we'll do the horizontal shrink and stretch. It'll push the function that way, or we'll pull it that way. To make life easier, before we start, let's review some stuff. We've actually done this before in chapter 1. What does that represent? What does that equation represent? From chapter 1, section 5 or 6, or 4, maybe 4. Yep. This is an equation of a circle. Centered where? Where is it centered? Very good. And this is an equation of a circle centered where? in this equation, where's this one centered at? Yep, at the origin, 0, 0. Let's again, this is just a review. Where is the center and what's the radius? Nope. -2, 3. And the radius? 2. Very good. Because this is r squared. 2 squared is 4, so that's radius is 4. Okay, this is what I was looking for. It's more important here. Whatever happens inside the parentheses, it's always the opposite. If I have x plus 2, the answer is -2. If it's y minus 3, the answer. Why is that? Why is it always the opposite if it's inside the parentheses? Because we went from the center to this new location. The h here is 0. So x plus 2 equals 0. X will have to be -2. Y minus 3 equals 0, because we want to get back to the origin. So y equals 3. So if it's inside the parentheses, it's always the opposite, the answer. Which direction does this one move? How many spaces? Right. It moves left 2 spaces because it's plus 2. And this one moves. Nope. It's the y values. Up 3 spaces. Again, it's the opposite. It moves left 2 spaces, up 3 spaces. That's what that just did. That moved your center from 0, 0 radius 2. It changed it to -2, 3. There is your new origin. So you go up 2, down 2, and draw your circle. We did those transformations in chapter 1. It's going to be the same this time. No. If it happens inside the parentheses, then it moves horizontally. If it happens inside the parentheses, it moves horizontally. And the value is the opposite sign. Oops. Oppo sign. Opposite sign. So if it happens inside the parenthesis, then it moves horizontally. And it has the opposite sign. If it happens outside the parentheses, then it moves vertically and the sign is what it is. So here's 1, 2. Now, this is going to help us throughout this whole transformation sequence. The parentheses represent the function. So if it happens inside the function, then it's a horizontal shift. If it happens outside the function, it's a vertical shift. Inside, it's always opposite. Outside, it is what it is. These little clues are going to help us with all 5 of these transformations. Put your phone away. Okay. Let me show you what a function looks like. We'll be using this format the entire time. This is a function. For example, it could look like something like this. There's the A. This one's the A. Here's the function. The function is a square root, but it has to be one of those from the library function sheet, which you're supposed to have memorized. Whatever's in front of your X is your B. Whatever's after the X inside the function is your C, and whatever's outside is your D. Each one of these contributes in some way to the transformation of the graph. The horizontal shift, let's look at that. The horizontal shift relates to the value of C. C is whatever's inside the function that's added to or subtracted to or from X. That's what C is. It's inside the function. It's added to or subtracted from X. So if I gave you the function of here are the steps. First step. What is the basic function of this example? From the library table, functions. What's the basic function here? It's a radical. So that's what we're starting off. And what does that graph look like? That's not memorizing, that's looking at the chart all the time. The radical looks like this because we cannot have negatives inside there. So that's the first thing. Let's first figure out what we have. The next thing we do, is there any change inside the function? Well, our example had, here's the function, it's x minus 3. So whatever's happening inside here, that's your horizontal shift. It's inside the function. Which direction does it go? How many spaces? Anybody? Which direction does it go and how many spaces does it move? Look at your notes. Goes right 3 spaces. Very good. Because in your notes, I just told you, if it's inside the function, if it's added to or subtracted from x, it's always the opposite sign and it's a horizontal shift. Writing notes is only one part of school. You have to understand what's being said as well. If you don't understand what I'm talking about, you have to ask questions. Because we just talked about this not even 5 minutes ago. What was this all about? So it's the opposite sign. Basically, what I'm doing, I'm taking what's inside the function, setting it equal to 0. So my new origin has shifted to the right 3 spaces. So the graph looks the same, but it starts there. Graph that one. And the rest of y'all, I know you didn't memorize it, so I would take out the library of functions sheet that you'll need to do this, and it'll help you draw the graph. Because I know you don't know what this graph looks like. The first step is what? What's the basic function? What is the basic function here? Again, you can't learn by listening to me. You got to do something on your end. Let me tell you the reality. Yes, it may seem easy. I can easily make an A in this course because I'm letting you do it at home and everything like that. If you're using that as a stepping stone to go ahead and cheat and get an easy A, I'll give you the A. Just stop showing up here. But also sign me a contract saying that you will not blame me when you fail your next math course because you don't know anything. You have to do your work. You have to know this stuff. I asked you guys 2 weeks ago to memorize these tables. So I don't want to be blamed for you failing every math course after this because you didn't bother doing it. It's just too easy to make an A. If it means that much to you, I'll give you the A. Just get out of here. So what's the basic function here? What is it? The rational 1 over x. What does 1 over x look like? What quadrants is the graph in? Yeah, for the three of y'all who are looking at your notes, thank you. The rest of y'all, I don't know what you're going to do. But remember, I always have the right to reserve having the final exam in this room. Yes. I have to get you another one. Yeah. Because if this continues, then we may have tests in the testing center. Library function sheet, yeah. Because you guys are trying to slack way too much in this class. This is a college math course. Is there a horizontal shift? Which direction? How far? Very good. Because the change happens here. Why is this a horizontal shift? Because I change x before I do the function. So my horizontal shift is to -2. So that's my new origin right here. So the graph looks the same, but over there. It's in the first and third quadrants. That's the horizontal shift. The vertical shift relates to the value of D. It's outside the function. So we find the value of y first, and then we add or subtract the other values, the outside values for y. That's why it's a vertical shift. It moves it up and down. Okay, here are the steps. Well, the basic function, we'll look at the basic shape. The basic function is what? The cube root of x. What does the cube root of x look like? Yeah, like a little stretched out s. Because it's the same as the square root function, but since it's an odd exponent, we can have negatives also. Is there a horizontal shift in this function? In other words, inside the function, is there an x plus? There is none, so it stays where it is. Then we look at the vertical shift. Is there anything outside the function? There's a -2 outside the function. So that says we move our origin from there, we go down 2. And there's our new x-axis. The graph looks the same. Graph this function. What's the basic function? No. Absolute value of x. The absolute value of x looks like a what? A v. Is there a horizontal shift? In other words, inside the function, is there anything added or subtracted to x? No, the horizontal shift is always the same way. It's to the left 2. Oh, I see. Yeah, because absolutely no. Is remember whatever's inside the function, take it and set it equal to 0. I never thought about that, but good thought. So we move it to the left 2 spaces. So our new origin is now here. So our graph shifted to the left 2 spaces. Now, is there anything added or subtracted to the function? Yeah, -3. So from -2, we go down 3 spaces to our new origin. And the graph looks the same. Up until now, all we do is just move the graph, the basic function, up, down, left, right. Now let's look at reflections. What's a reflection? A mirror image, yeah, opposite, exactly. Both are exactly correct. It's the opposite or the mirror image. So the mirror image, the reflection of this one, if we flip it across the x-axis, it will look like this now. If we flip it along the y-axis, it'll look the same. So about the x-axis. If something flips across the x-axis, what values change and how do they change? In other words, if I had this point here at 2, 3, what would be its mirror image across the x-axis? No, because remember, the x-axis is vertical. I'm just taking this top and just folding it down. So it would be +2, -3. Let's see. If I had the point -2, -2, and I flipped it across the x-axis, what's my new point? It's -2, +2. Because I started off at -2, -2. If I flip it across the x-axis, it's -2, +2. So what's the difference? What's happening here? Do the x change signs? Do the y's? Yes. So when you flip across the x-axis, the only thing that changes is the sign of the y. Y changes sign. So how would that look on our function? Remember, in function notation, those mean the same thing. And if y changes sign, is it A, B, C, or D that changes? Remember, our function looks like this. This is what our function looks like. So what makes the function change, the y change signs? This one deals with A. Because D is a vertical shift. It doesn't change the direction of the graph. If A is negative, then we flip across the x axis. Because it goes from a positive y, it's being changed to a negative y. Here's an example. The basic function is the square root of x. That graph looks like this. Well, since a is equal to -1, which is less than 0, we flip across the x-axis, and our graph looks like this now. Remember, if it's outside the function, it's vertical. It's a vertical flip. If it's inside the function, it's a horizontal flip. If A is positive, there is no vertical flip. So it only affects it if the sign is outside the function, if it changes from positive to negative. All right, let's look at if it's about the y-axis now. we're flipping across the y-axis now. This point here is 3, 2. If I fold the sheet over, I'm going to have a point here at -3, 2. At -1, -3. If I fold the sheet over, I get +1, -3. So if it's about the y-axis, the x's change signs. And remember, x's are inside the function. If it happens inside the function, it's a horizontal change. If it happens outside, it's a vertical change. So this is the value of b. Remember, we have our function af bx plus c. Now we're looking at the value of b, the sign, not the value. If b is positive, there is no horizontal flip. If b is negative, then rotate your graph about the y-axis. It's a horizontal flip. That one's yeah. The basic function is the radical of x. We first look at, is there any horizontal shift or any vertical shift? And 2. Horizontal rotation. Does the sign of x change? If it's inside the if it's inside the function, then it rotates about the y-axis. If it's outside, it rotates about the x-axis. But think about this. Can you take a square root of a negative number? That's how come the graph only goes this way. So if x is negative, the only way we can cancel out this negative is if x is negative, because negative times negative cancel out. So that's how come the graph looks like this. What's the basic function here? Mhm. And that looks like this. Let's build our way out. Is there a horizontal or is there a rotation? Horizontal rotation. In other words, does X change sign? Yes. So we know it rotates this way. We have an equation inside the function. That means it's a horizontal shift. How far does it move? In which direction? Remember, take this function, set it equal to 0. I move the X over. So it moves to the right 3 spaces. So my graph looks like this. Is there a vertical rotation? In other words, is there a sign change outside the function? Yes, it changes. So our graph now, remember we shifted to the right 3 spaces. It was pointing this way. Now we flip it across the x-axis. It looks like this now. Because of this. Yes. This is the rotation. This is because it's outside. This one is a vertical shift, a rotation. Then, then is there a vertical shift? The vertical shift is the d value. Is there anything added or subtracted from the function? It's going up 2. So we shifted to the right 3 spaces. Now we're going up 2. So 3, 2. This is where my new origin is. My graph looks the same from there, from the previous step. And there's your answer. So what transformations really do is they're changing the origin to a new location and flipping the graph. We haven't changed the shape of the graph yet. We just changed the location of it and the direction. Now comes changing the graph itself. Vertical, shrink, or stretch. If it's vertical, where does the change happen? Inside or outside the function, if it's vertical? outside. So the only one that can change it is the A factor. Earlier for the rotation, we only look if it's positive or negative. Now we look at if A is, or absolute value of A, if it's bigger than 1, if it's bigger than 1 or less than -1. This is a vertical stretch. Basically what's happening here is your old point, your original point of your graph looks like this. Your new point will be whatever A is times your X value or times your Y value. The basic function is the square root of X. Let's look, now we're going to look at some points actually. So when X is 0, Y is 0. That's the origin. When X is 1, square root of 1 is 1. So when X is 4, Y is 2. So that's the original function. And we have a vertical stretch because A is bigger than 1. Actually, A is equal to 2, which is bigger than 1. So what that means, we multiply the Y values by A. Because this was the original graph with 0, 1, and 4. This is my X, this is my Y, this is my X, these are my Ys. Now, since my function says 2 times radical X, I take this value, multiply by 2. So the original function looked like this. That's square root of X. My new function looks like this. I pulled it up. I stretched it vertically. So you see how These are your old points. These are your new points. 1, 1. It then became 1, 2. 4, 1 or 4, 2 became 4, 4 because I multiplied by 2. So if it's outside the function, it affects it vertically. If it's an integer bigger than 1, it's a vertical stretch. If a is a fraction, then it's a vertical shrink. I push the graph down. We'll stay with that graph. Remember, a is whatever's in front of the function. A is whatever's in front of the function. Here's the function, so this is a. A is between 1 and 0 and 1, so it's a fraction, which means if we look at the values of this, the original function is a square root of x. This is the old, this is the new. Square root of 0 is 0. So our graph starts off at the origin. When x is 1, y is 1. So that's this one. When x is 4, y is 2. That's that graph. But now, for the new one, since my coefficient a is 1/2, I take whatever I have here, divide it by 2. So at 1, I got 1/2. At 4, 2 divided by 2 is 1. You notice how it's being pushed down. So if the coefficient in front of your function, in whatever the weird part of the math is, then you know it's going to be shrunken. But again, you see how important it is to know the basic function already? Because if you know the basic function, you know what the basic shape of the curve is going to be. You don't have to go looking for it or make your own tables. You know what it's going to look like. Okay, so that was vertical shrink and stretch. Again, remember I said, if it happens outside, it is what it is. If it's a times 2, you multiply by 2. If it's divided by 2, you divide by 2. But if it's inside, it's opposite. So this, and if it's inside, it's horizontal. Horizontal shrink and stretch. So what value are we going to look at here, you think? We're going to get B. The coefficient of X. So we're looking at the value of B. If B is greater than 1, then we have a horizontal shrink of X over B. What's happening here is this. We're going from our old point to our new point. It's going to be X over B, Y. So if it's greater than 1, we divide by B. If B is a fraction, then we have a horizontal stretch of X over B. Now that's going to look strange. Because they're saying, but they're exactly the same things. But they're not. Let's look at this one. What is my B value in this first one? 3. What is the B of this one? Very good, 1 over 3. Because remember, if you have fractions, you can always split them up. Okay, so once we have our B, let's look at our new points. It's X divided by B. So if we have X divided by B, which is going to be X divided by 3, that's just 1/3 the value of X. Not a problem. But in this case, we have X divided by 1 over 3. We have a compound fraction. It's X divided by 1, divided by 1, divided by 3. Take the top fraction, leave it alone, and flip the bottom. So now we're stretching it. This is a stretch. This is a shrink. So if your B is an integer or larger than 1, we have a shrink. If your B is a fraction, then we have a stretch because you're dividing by a fraction. Now, the question you may have is, how come it is that? Because remember, what do you do with whatever's inside the parentheses, inside the function? What did you do there? Well, for horizontal shift, we took what was inside, set it equal to 0, and found a new X origin, a horizontal shift. If we do the same thing here, then we subtract 1 and divide by 3. So X equals negative 1/3. So this 3 is becoming a fraction. It makes my value 1/3. Let's say my function, let's say my function was this. 2f of negative 3x. That's my function. Whatever the function is, doesn't matter. I'm going to give you these points. These are my old points from the original function. Tell me the value of my new points. What does this one represent? What letter does this one represent? A. And this one? B. What can you tell me about these things? A deals with which value, X or Y? Right, because it's outside, so it's vertical. It deals with the Y values. So whatever I have for the Y values, I multiply by 2. Because A equals 2. I multiply all the Y values by 2. But B is a 3. That's larger than 1. So what do you do for the X values if it's larger than 1? Remember, it's opposite. You divide it. So this one's going to be negative 2/3 because that's negative. This one's going to be negative 9/3, negative 3 over negative 3. So our new points are these. Because B is equal to negative 3, we divide the X's by 3. Multiply the Y's by 2. Because this is really what's going on whenever you have coefficients in front of your functions.
Sketch that one.